Sivaram, Assistant Professor from the Department of Naval Architecture and Offshore Engineering. So today I'm going to engage basic concepts of thermodynamics from the course Thermodynamics and Marine Machinery. Thermodynamics. So thermodynamics refers to the branch. Thermo stands for heat and dynamics stands for the flow of heat. So thermodynamics deals with the flow of heat. So wherever heat transfer is involved, thermodynamics plays a significant role. So in this session, we are going to see about the basic concepts about thermodynamics. Law of conservation of energy. Actually, first law of thermodynamics is based upon law of conservation of energy principle. But in basic concepts of thermodynamics, of course, law of conservation of energy has its role. So law of conservation of energy, it states, energy can neither be created nor be destroyed. It can only be transferred from one form into another form. So energy can neither be created nor be destroyed. And working substance. Actually, the primary fluid which is present in any system is the working fluid. For example, for an air compressor, air is the working fluid. And for a diesel engine, diesel is the working fluid. And for a petrol engine, petrol is the working fluid. So the primary fluid which is present in any substance is the working substance for that particular system. So in whichever systems, heat transfer plays a significant role. So in all those systems, thermodynamics plays a significant role. For example, starting from refrigeration systems, air conditioning systems, heat engines, power plants, and again aircraft applications. And wherever applications we do involve heat transfer, in all those places, thermodynamics plays a significant role. First, we will see what are all a few basic properties and what is the meaning of those properties. First thing, density. Density is nothing but the ratio of mass to volume. And specific gravity. Specific gravity is nothing but it is the ratio of the density of given fluid to the density of standard fluid. Usually standard fluid here it is taken as water and the density of water is around 1000 kg per meter cube. And coming to the next one, specific volume. Specific volume is nothing but the volume occupied by unit mass of substance is specific volume. A unit for specific volume is in terms of meter cube per kilogram. Coming to the next property, I can say pressure. The force acting per unit area is pressure. So force acting per unit area. So obviously the unit for force is Newton. The unit for area is meter square. So for pressure is expressed in terms of bar Newton per meter square. Coming to the next few terms, atmospheric pressure. The value of atmospheric pressure, we usually refer it as 1 atmosphere. The value of 1 atmosphere is 1.013 bar. We also give occasionally normal conditions of temperature and pressure and standard conditions of temperature and pressure. There are 3 types of pressure. So I can say first pressure is gauge pressure. Pressure gauge is an instrument used for recording pressure and pressure gauge reads only the pressure present in the system. It does not consider the atmospheric pressure into account. And coming to absolute pressure is nothing but along with gauge pressure, we also consider what into account is atmospheric pressure into account. So mathematically, absolute pressure can be expressed as the sum of gauge pressure and absolute pressure. And coming to the next pressure is vacuum pressure. The negative pressure is termed as vacuum pressure. That is, the pressure below atmospheric pressure of 1.013 bar is termed as vacuum pressure or negative pressure. And these are all the 3 types of pressure. Coming to temperature. The degree of hotness or coldness of a body is expressed by temperature. And temperature is expressed in 3 different scales. It is expressed in degree Celsius, Fahrenheit and Kelvin. So this is what temperature is. Again, as said earlier, standard conditions of temperature and pressure is 15 degrees Celsius and 1 atmosphere, that is 1.013 bar or 760 mm of mercury. Normal pressure is atmospheric pressure 1.013 bar and normal temperature, you can occasionally normal temperature is taken as 0 degrees Celsius. So this is about standard temperature and pressure and normal temperature and pressure. And coming to approaches in thermodynamics, basically there are 2 approaches in thermodynamics, statistical approach and classical approach. Classical approach is otherwise called as macroscopic approach and the statistical approach is otherwise called as microscopic approach. So So macroscopic approach. In case of classical approach or macroscopic approach, the study is made with respect to the system as a whole. But coming to microscopic approach, any substance is made up of atoms and molecules. I need to make a study at molecular level or atomic level. So that is microscopic approach, which can be done by using a scanning electron microscope or transmission electron microscope. Next, we are going to see about system, surroundings and boundary. So system, thermodynamic system is nothing but an enclosed space that is chosen for study. I'm going to choose an enclosed space or a defined space for any study, and that is referred as thermodynamic system. And boundary, I can say surrounding. The space outside the system is surrounding. The layer which separates system and the surrounding is boundary. So I can say confined area chosen for study is system, area outside the system is surrounding, and system and surroundings are separated by means of a boundary. Coming to next part, three types of system, types of thermodynamic system. First type, it is closed system. In case of closed system, energy transfer only takes place, no mass transfer takes place. Open system, coming to open system, in open system both mass transfer and energy transfer takes place. I can say turbine is a typical example of open system, and boiler, where water enters a boiler and water which is entering the boiler leaves out as a steam. So I can say boiler is a typical example of open system. And the next thing is isolated system. I have a system where no mass and energy transfer takes place, and that is isolated system. Practically, isolated systems don't exist, because if you have any system, in that either mass transfer or energy transfer is likely to take place, and control volume is nothing but a specific volume, a specific defined volume within the system is controlled volume, and boundary can be a fixed one or boundary can be a stationary one. When I take a system which is separated surroundings by means of a boundary, the boundary either can be a fixed one or else the boundary either can be a movable one. So this is about different types of system, and system, surroundings and boundary. So this part we come to an end, and in the upcoming session we will be seeing about laws of thermodynamics. Thank you.